Hello everyone, my name is Ankit Nanwal and today we will be learning about making ILD for shear force and ILD for bending moment. So first of all, we will be learning about ILD for shear force. So ILD for shear force. Okay. In early lecture you have learned about making ILD for the reaction. So in case of shear force, suppose this is the beam here. This is the simply supported beam. Okay, this is A point, this is B point. Okay, now suppose I have taken a section here, this is C point. Okay, this is section X. So for making ILD for shear force diagram, first of all you need to consider the unit load is at AC. So first condition is that you need to consider that the unit load is at AC. Okay, this 1 kilonewton load is at AC span. Okay, so this span is in previous lecture I have taken this distance as A. This will be L minus A. Okay, I am taking same example for the simplest moving. So this distance will be X. Okay, now for making the shear force diagram, first condition is that the unit load is at AC. So then you have to write the equation for shear force at C. So at this point, when you are talking about point C, you need to put your hand here and see the equation from left hand side. Okay, so what will be the equation? Here there will be one reaction, that is RA, one will be HA. Okay, here one equation will be RB. So first of all, before writing that equation, you need to get the value of Ra and Rb. How will you get that value? You need to apply the equilibrium equation, that is summation fx equal to 0, that will give you Ha equal to 0. Second equation will be summation of fy equal to 0, that will give you Ra plus Rb equal to 1. Same equilibrium equation. The third equation will be that you are considering the moment about A point to be 0. When you are considering the moment at A point to be 0, you need to put your hand at A point and see the equation from right hand side now. So it will be RB minus minus RB into L minus 1 into X equal to 0. From here you will get the value of RB as X upon L, and put this equation in first equation. This is first equation, this is second equation. Put second in 1, you will get Ra value will be here Ra plus Rb equal to 1, and Ra value will be 1 minus Rb, and Rb value is x upon L. So you will get your L minus x upon L. That is the value of Ra. So now you have the value of Rb and Ra. This is the similar procedure that you have followed in calculating the reaction. Okay, now we come to shear force diagram. Now you have to get the equation of shear force at C point. Now put your hand at C point and see the equation from left hand side now. Okay, I have covered this span from this hand. Okay, so now I can see only reaction Ra and one unit load here. So what will be the equation at shear force at C will be Ra minus 1. And what is the value of Ra? We have calculated here L minus x upon L. L minus x upon L minus 1. Now you need to solve this equation. You will get L, that is L minus x minus L. So you will get minus x upon L. Okay. Now you have to consider the second condition, as the second condition will be that the unit load is in span CB. Now unit will load, this unit load will be in span CB here now. Okay, when this unit load will be at CB, so what will be the equation? Shear force at C will be, if you are seeing the equation from left hand side, what will be the equation? So at that point, now this load has gone from here to here, so there will be no one unit load at that point, and this condition is valid only when the x value is greater than a and less than equal to l. Okay, so this condition is valid for, this is the boundary condition for the value of x. Okay, so now when it is at span CB, what will be the shear force equation at C? Only Ra from left hand side. Now I am seeing from left hand side, this side I am seeing the equation from left hand side. As this unit load has gone here now, so only one reaction will be here when I am seeing the equation from left hand side, that will be Ra. Okay, so now the equation is Ra. So Ra value will be L minus x upon L. So shear force at C is this. Now if I want to calculate the shear force when the unit load is at AC, when the unit load is in span AC. Now when it is in span AC, so this condition you can see EC AC, so x will vary from 0 to A, x will be varying from 0 to A, x here will be 0, and from here it will go here from 0 point, here from 0, and it will vary till A because it is in span AC. For that condition you need to calculate the value of shear force. Now for shear force value is this, put the value when x equal to 0. When x equal to 0, the shear force at C will be 0, and when x is equal to A, shear force at C will be minus A upon L. So this is the shear force value, minus A upon L. Okay, now there will be two conditions for the unit load is an span CB. Okay, for that x value will be equal to A, and it will vary from A to x equal to L. Okay, now put the value in shear force. Shear force will be, for first condition will be L minus x, that will be L minus A upon L. Okay, and when x equal to L, that means shear force at x equal to L will be 0. Now you have the values of shear force. Now you need to make a shear force diagram. So now this shear force at C will be L minus A upon L. Influence line diagram for the shear force. Now influence line diagram for the shear force will be, now this is the span. Now at this point x value is 0, so the unit load is in span AC, x value 0, so shear force value is 0, so it will start from 0 here, and at C point, suppose this is the C point, this is the A point, this is B point. Okay, now at B point, C point, the shear force will be minus A upon L. So when the unit load in span AC, so it will be minus A upon L. So minus A upon L means here, minus A upon L. Minus means downwards. Okay. Now from here C point, now see the second term, that when the unit load is in span CB, at that point shear force will be L minus A upon L, that is positive, and it will be somewhere here, that is L minus A upon L, and from when the x equal to L, the value is 0. So this is the influence line diagram for the shear force. This is how you need to make a influence line diagram for the shear force. Okay, I hope these points are clear with you. Influence line diagram for bending moment, Okay, so again you need to consider the same example that this is a simply supported beam here. Okay, this is the C section that I have cut at. This is A, this is B, and this is C. This is the section that I have cut here. Okay, now first we will be considering that the unit load will be in span AC. Okay, this distance will be X, this distance will be A, and this distance will be L minus A. Okay, now when we have considered the unit load in span AC, so you can write down unit load in span AC. Okay, so you have to consider the bending moment equation at C. You need to consider the bending moment equation at C point. So what will be the bending moment equation at that point? Now you know the value that there will be two reaction, one is RA and one is RB. This is HA. Then again you need to calculate the same result for these two, and you will get the value of RA as L minus X upon L, and RB value will be X upon L. Okay, so this was the value of RB. RB value was X upon L. Okay, now similarly after applying the equilibrium equation you will get these value of RA and RB and H equal to 0. Now you have to write the bending moment equation at C. So what will be the bending moment equation at C? You have to put your hand here now. You need to cover this point CV span and see the equation from left hand side. So what reaction you can see? RA reaction and one unit load here. Okay, so two reaction you can see. So bending moment will be combined with these two forces. So one force will be providing clockwise moment, one providing anti-clockwise moment. So RA will be providing clockwise moment as we want to go to C point. Okay, so this will be bending the beam like this. So L minus X upon L, this is equation will be RA, and this distance we need to go to A, RA into small a. This is the clockwise moment, and anti-clockwise moment will be 1 into, and distance will be this. This distance is total is A, this is X, so remaining will be A minus X. So here you can write down A minus X. Okay, so what will be the equation? RA value is L minus X upon L into A minus A minus X. Okay, so this is the equation of bending moment when the span a unit load is in span AC. Now you have to consider the second point. Now you have to see the boundary condition. The X value will be varying from X equal to 0 to X equal to A. Okay, now when X equal to A, then bending moment equation at C will be, you can see bending moment equation when X will be 0, that means the bending moment at A we are talking about. So bending moment at A, this equation will be L minus X A. So put the value X equal to 0, that will be L upon L, that means 1, that means A minus A plus X. So this will be bending moment will be X, and X value is 0. So this means bending moment at this point will be 0. Now for second condition, when X equal to A, put the value bending moment at C for that point. When X equal to A, that means bending moment at C we are talking about. Okay, now bending moment at C will be L minus, put the value X equal to A, okay, into A upon L minus A minus A will be 0. So this term will be 0. Okay, now we have the equation this. What is the equation? That you can write down LA minus A square upon L. Okay, so this is the two condition you have got when the bending moment is at A, when the bending moment at C. Now consider the second condition, that unit load is in span CB. Now when the unit load is in span CB, you can see this one, that this unit load is now here. Okay, when this unit load will be here, you can see the bending moment equation will change. There will be bending moment equation will only be having RA reaction with, and this unit load will not take part in that. Okay, so bending moment equation at C you can write down then will be RA into the distance is A, RA into A. This is RA and this is A. This unit load has crossed this point, so there will be no part of that. So RA into L, so RA value is L minus X upon L into A. Now for this you will be having two values. When X, this condition is valid for that X is greater than A and less than equal to L. Okay, so X value will be varying from A to X equal to L. So for first condition, when X equal to A, the bending moment will be at C. So XA will be L minus A upon L up into A, and this will give you AL minus A square upon L. So this is bending moment equation at C. Okay, now when you are putting X equal to L, then bending moment equation will be at B point because X value is L. Okay, so put this in equation, that will be L minus X, and L minus L will be 0. So this term has is L minus L upon L. So L minus L will be 0. So this term is 0. 0 into anything is 0. So bending moment at B will be 0. Now you have all the values. So you can see now span, this is A point, this is B point, and this is C point, suppose. Okay, now what you will do at A point, you can see the bending moment at A when the unit load is in span AC. So bending moment at A at that point we got the equation as 0. Okay, so here bending moment was 0, and at C now see the second condition, when the bending moment equation at C when the unit load is in span AC, we got the value as LA minus A square upon L. Okay, so this is the equation here, that is A bracket L minus A upon L. So this was the equation. Okay, now see for second, when the second condition that unit load is in span CB, for that bending moment at C we get the similar value, that is A L minus A upon L. That means the point is same at that point, and bending moment at B is 0. So the influence line diagram will be like this. Okay, this should be straight. Okay, so this is the influence line diagram for the bending moment. So this is how you need to draw the influence line diagram for the shear force and bending moment. I hope these points are clear and you guys are getting this concept. If you have any doubt, you can contact me. Okay, thank you very much.